Am I audible? Am I audible? Hello. Okay. So in the previous session we discussed about CRC. Okay. We just gave an introduction about CRC. So basically CRC means cyclic redundancy check. So and we already discussed in the previous session, before we discussed about CRC, we have discussed about EEPROM library. So EEPROM means electronically erasable programmable read-only memory. So we discussed about EEPROM library, just like which is equivalent to non-volatile storage in ESP32. Okay. So we discussed that this particular thing what you are seeing right now, this is called as CRC table. Okay, this is called as CRC table, cyclic redundancy check table. So this table is predetermined. Whatever the values that it is containing, all these values are hexadecimal values. Okay, all these values are hexadecimal values. So and each value, why see all these values we are having in the table, total there are 16 values, right? So all these 16 values corresponds to 4 byte integers. Okay, each particular one, individual one, contains 4 bytes. So everything, okay, in this total 16 items inside the CRC table array, so each one consists of 4 byte. Okay, so all are integers, but they are given represented in a hexadecimal format. So where each number corresponds to 4 bytes. Okay, one each value, each hexadecimal value here containing total 4 bytes of memory. So we discussed that EEPROM is used to check whether the data which is present inside the EEPROM memory is corrupted or not. Okay, to determine whether the data which we stored in the EEPROM and what we are fetching are both same, or is there any corruption happened for the in the data. Okay, so how we performed the check? So I will just give you an overview because Ibrahim missed the yesterday's session. So I will just give you the overview of CRC, and then we will jump into how this CRC is actually performed. Okay, so as of now what you need to understand is that whatever the values that we are containing over here in the CRC table, all these values are predefined values. Okay, so those values are predefined. You can directly, you just no need to think about anything, you can directly put these values, copy paste. So is there any other way through which I can reconstruct these particular values without remembering, nor without seeing any kind of or copy paste? Yes, there is a possibility. There is a mathematical approach. Through that mathematical approach, you can reconstruct the entire CRC table. Okay, you can reconstruct the entire CRC table, like you can generate all these values mathematically, but that is little bit complicated, which we will be discussing in the upcoming session, not in this particular session. So it will take around 2 to 3 sessions to explain you how to construct a CRC table on our own through mathematical approach. Okay, so but as of now we will focus on how to check whether the data that we stored in the EEPROM memory is corrupted or not. Okay, so that is the main objective behind the CRC. Okay, now here you can see uh, here we have taken two characters. Okay, letter 1 and letter 2. So for first one, for the letter 1 we have assigned H, and for letter 2 we have assigned I. So we are defining this particular variable as the data type char. Char means character. So character means ASCII characters like A to Z, capital A to Z, small a to Z, and 0 to 9. So all these values. Okay, each character, see whenever we are using the data type character, so usually each character refers to each character refers to 8 bits of memory. Okay, that means 1 byte. 1 byte. So when we are discussing about EEPROM memory, so we discussed that in EEPROM memory there are multiple locations. Okay, you can store the data in any location, but each location can store only some specified amount of data. So Ibrahim can just tell me how much amount of data can each location which is present inside the EEPROM can store? Any idea? In EEPROM memory we can store data. There are multiple locations. Okay, so starting from 0 all the way up to 255. So total 256 locations are there in EEPROM. So in this 0 to 255, so in each location it can store only a specified amount of data. So how much data can it able to handle? Any idea? So is it 1 byte or 2 byte, 3 byte, 4 bytes? How many bytes of data can it store in each location, individual location of EEPROM? 4 bytes. No, no, no. Actually, it's not 4 bytes. Each individually it can store only 1 byte of memory. See, we already discussed about EEPROM library. So if you have forgotten that, kindly go back to that EEPROM session and just go through that. So in that session where we discussed how to store some memory in EEPROM and how to fetch that memory. Okay, so that session is already over. In that we discussed that total there are 0 to 255. That means total including 0 256 locations are there in EEPROM. Each location can store only 1 byte of memory. More than 1 byte you cannot store. That will cause a data overflow error. It cannot store more than 1 byte. Okay. So now coming to this particular thing, yeah, let's come to here. I already told you that each character, okay, whenever you are using the data type character, so each character refers to 8 bits of memory. So 8 bits of memory which is equivalent to 1 byte, which is exactly equal to the maximum threshold data that can be stored in each individual location of a EEPROM in the EEPROM memory. Okay. So now to store the data in EEPROM memory, we need to use the write function. Okay, EEPROM dot write method. Okay, write function. So this it accepts two parameters. The first parameter is the memory location. Okay, the first parameter is the location, and the second one is data. First parameter is location, and second parameter is data. So the first parameter I told you there are total 0 to 255 locations are there in EEPROM memory. Coming to data, so whatever the data that you are storing, it should be equivalent or less than or equal to. In other sense, less than or equal to 1 byte of memory, memory space. So it should be less than or equal to 1 byte of memory space. You cannot, if you want to store less than 1 byte, you can store, but you cannot store greater than 1 byte in each location. Okay. So that is about the write function. Yeah. So in location number 0, we have written the first character, and in the location number 1, we have stored the second character I. Okay. So on the first location, we stored the first character H, and second location in the sense 1. Okay, because location address starts from 0, not from 1. Okay. So 0 at 0th location in EEPROM memory we have stored H, and the next one, okay, followed by after 0 the first location, we stored the character I in the EEPROM memory. Now the data is right now inside the memory, EEPROM memory. So see, along with storing the EEPROM memory, there is one more thing that we will see. This is optional. Okay, it's not mandatory that if you are storing any data in the EEPROM memory, you need to store CRC. That's completely optional. So if you want to perform the error detection check, or else if you want to do whether the data which is stored inside the EEPROM memory and what we are retrieving it later, both are same, or if it's if it's got corrupted, if you want to detect that corruption detection, so for that you need to use the CRC. Okay, then you need to store CRC inside the EEPROM memory. So by default it's not necessary. So the reason is that if you want to if you want to perform the data modification, or else whether the data get altered, okay, you want to perform the corruption detection, because data is prone to corruption. Okay, there could be multiple reasons. Sometimes even a single bit, instead of 1 if it's a 0, or in place of 0 if it's 1, so just 1 bit if it's inverted, the entire value will be changed. So that's why we need to perform the CRC check. Okay, which means CRC means cyclic redundancy check. So here you need to so actually today we need to discuss about how this CRC is generated. Okay, that we will discuss. So I will just give you the basic overview of this particular code, and then we will directly jump into explanation of the CRC. Okay, so by that today's session would be completed. So yeah, So here we have defined one function, right? Calculate EEPROM CRC. So this is not an inbuilt function. It is an user defined function. That means you are defining this particular function. And I am sure that you know the difference between inbuilt functions and user defined functions. So inbuilt functions are that comes directly with the uh, you know the environment. I mean, which are defined in the core libraries. Okay, those are the inbuilt functions. Whereas these calculate EEPROM CRC and whatever the functions that you are specifically declaring yourself, those functions are actually called as user defined functions, which are defined by the user, not by the system. So system defined functions are um, those functions which are defined in the core libraries, the deep core libraries, those are called as built-in function. So this is a user defined function. That means we defined this particular function. So this function is designed in such a way that when this function is called, okay, at the end it is returning some output. Okay, when this function is called, it is returning some output. So this output is returned based on one parameter, because this function is accepting only one parameter, and that parameter is data size. Okay, so this particular function is accepting only one parameter, that is data size, which is of integer data type. And when this function is called, finally it is returning something which we are referring it as the CRC. Okay, so this is the main function which is actually generating the CRC, and this entire thing is dependent upon the data size that you mentioned. Okay, so here again we have taken one variable generated CRC. Okay, and we have also fired the function, called the function calculate EEPROM CRC, which is defined over here at the beginning of the program over here. And we are passing one parameter as well. Okay, uh, one argument, we are passing one argument. So now the value is 2. Why 2? Because we are storing only 2 characters. Okay, so 2 bytes of memory, we are storing 2 bytes of memory. The number of bytes that you are trying to store in the EEPROM memory, the same number of bytes here you need to pass as the parameter. Okay, for the parameter you need to pass the argument. Okay, yeah. So here, since we are storing 2 bytes of memory, first byte is high h. In high, first letter, first character h, that is the first byte, and next character I, which is the second byte. So total high consuming 2 bytes of memory. So that's why we have passed 2 over here. So finally generated CRC will be taking some encoded form. Okay, see, CRC is something like you're storing some memory inside the EEPROM. Okay, that's what we performed over here, and then you are passing the size of the or else you are encoding whatever the data that you have stored inside the EEPROM memory. You are encoding that. Okay, through some mathematical approach, through some shifting operation. Okay, some binary operations, left shift or right shift, or exclusively OR gate, using some gates. Okay, you know about exclusive OR gate, you might have learnt in the lower standard. Even if you don't know, I will explain about it. Exclusive XOR gate. So basically we will be using some gates, or else some shifting operation. And finally what we are doing, from whatever the data that you are stored, okay, the same with the from the same data we are obtaining some encoded form. Okay, an encoded form. Okay, so that encoded form is here we calling it as the generated CRC. Actually it is also called as checksum. Okay, so the actual technical term is checksum. So checksum is something like the encoded version of the actual data. It's not, see, checksum is the not actual data. So our actual intention is to store high. This is the main data. But along with this particular one, again in the EEPROM memory, we are storing an encoded version of this particular data. Okay. So that's what generated CRC is. Now in the next part, what we are doing, we are not only, see, in the before generation of the CRC, we have stored the actual data. So once a CRC is generated, then we are storing the generated CRC also into the EEPROM memory. So not only we are storing the main data, we are also storing the generated CRC value in the EEPROM memory. Okay, so is it clear, Ibrahim, up to till here? Yeah. So actually this session is already completed yesterday, so I'm just re-explaining you, so kindly please focus. So before generating the CRC, we have only stored the actual data that we which we intended to store. But after the generation of the CRC, we are also storing the generated CRC value right after the just in the adjacent, okay, in the adjacent locations. See, the first data we stored at 0, then at 1. That by till here our actual data is completed. We have already stored successfully. Then we generated CRC, okay, and then the generated CRC is stored just after the actual data. Just after the actual data, generated CRC is stored. So then see by here, by this particular line, so now we have our main data stored into the non-volatile memory, okay, which is EEPROM, and then we are also the generated CRC or checksum, so which we also call it as the checksum. The checksum is also stored in the EEPROM memory. Okay, now in the next step, what we are doing, when we are trying to fetch the data, let's say after some point of time, after some duration, let's say you want to again fetch the data what you stored previously. So at the time of fetching the data, see, we already discussed about the read function. The write function is used to store the data, and the read function is used to retrieve the data, okay, to read the data. So now we are performing the read operation. So this read operation accepts only one parameter, that is the memory location. Okay, already we know that we stored the data at two locations, 0 and 1. At 0 H, and at location number 1 we stored I. So again now we are trying to fetch those particular values. Now fetched 1 becomes H, and fetched 2 takes the value I. Okay, so now not only we are retrieving the data, now see, already we stored the data and we retrieved the data, but that's not our intention. What the entire objective of the CRC checksum validation is that whether the store